These are the chapter 3.1 notes, function and function notation, page 1. So a little bit of a review at the top, those terms that we know and we just don't use as much. A function is a correspondence between two sets. Our first set, our input, is called the domain. And then our second set, our output, is called the range. So domain and range you want to be familiar with. Range, and I'm describing it with range. Because that you're going to be required to crank out all semester. So it's a function if there is only one member of the range that comes from each member of the domain. So that means that if I give you an x value, you can definitely tell me without question what the y value is that goes with it. So let's take a look at this first set. If I tell you that x equals -6, you would tell me that y equals 36. There's no question, there's only one y that goes with that x. If I tell you that x equals 6, you're going to tell me that y equals 36. It does not matter if my y's are repeated, as long as my x's are not repeated. So yes, this is a function. Each of these x's go to only one y. Let's take a look at that second set. If I tell you that x is -6, y is -2, that's okay. If I tell you that x is 6, y is 15, there's only one y. If I tell you that x is -3, you're going to tell me that y is 0, even if my arrow's a little off. If x is 3, we know y is 3, and if x is 0, we know that y is 4. So this is a function. A little disappointing. Both of these are examples of functions. So let's take a look at D. We want to use one of the diagrams above to show what it would look like if it were not a function. So let's take a look at this. I'm going to take a look at the second set because I have more options here. So I'm going to go -6, 6, -3, 3, and 0. You notice the domain in both of these functions are exactly the same. I'm going to go 4, 15, 3, 0, and -2. And suppose that my -6 goes to 4 and my 6 goes to 4. That's fine. We're going to make my -3 give me a 15. My 3 is going to give me a 3, and so my 0, we're going to go to 0 or to -2, which means that if I tell you x equals 0, you're going to tell me that y equals 0 or y equals -2, and that creates a problem for us. Okay? If x equals 0, then y equals 0 or y equals -2, that would make this not a function. Okay. It's a function if I can give you an x value and there's absolutely no question about what y is. There's no either or. If it is not a function, if we don't know yet if it's a function, we're going to call it a relation or a correspondence. So let's talk about the correspondence of people to birthdays. Is that a function? It is, because each person has only one birthday. And we're not talking about those people born on February 29th, which then is sometimes maybe celebrated as March 1st. Birthday still is February 29th. They may just celebrate it on a different day. What about if we go the other way? What about birthdays to people? And that one's going to be a no. That is not a function because a given date will have multiple people with that birthday. So it's all how you think about it. So notice our functions don't necessarily go both ways. So person to birthday is going to be a function. Birthday to person is not going to be a function. Okay, so the direction that we're moving matters. If there is a correspondence there, but it's not a function, we're going to call that a relation. And a relation is going to be that correspondence where each member of the domain corresponds to some member of the range, at least one.